your domain. You have to, that's the definition of a function, or part of the definition of a function. You have to map every element. Okay? Now, you're mapping to itself. So the size of this one is equal to the size of that one, because it's the same set, right? You're mapping to itself, and it's a finite set. And let's say the number of elements in your set A is little n. Okay. Now you're not allowed to have 2-to-1 mappings. So there are n elements here I have to map, and there are n elements here I can map into, or onto. Okay? Now, given I have to map every element in my domain, and I'm not allowed to map 2-to-1, can you see the only way I can do that is to map 1-to-1. Right? So every element here maps to one element in A. So effectively it's sort of like a permutation. What chapter was that? Maybe maybe I'm time traveling. Yes, that was chapter 12, sorry. Okay, but effectively it's a permutation. You're permuting these elements into these elements, just changing the order. But can you see that the mapping has to be 1-to-1, because you've got n here and you're mapping into the same set. You cannot have any 2-to-1s. Like imagine there's just one little element here that's a loner. Say it's that one, and say it is not mapped to. Right? And if that's the case, then this codomain here, or the mapping, is not surjective, by definition. Surjective means every element gets mapped to at least once, maybe more. Right? But we're told that this F is injective, right? So let's do a proof by contradiction. Let's assume there's one element here that is not mapped to. All right. Well, we have n elements in the domain, and they all have to get mapped, right? And we have n elements here because we have n elements here. It's the same set. Yes. All right. So we're mapping n elements into n elements, but this one does not get mapped to. So we have n arrows, n mappings, n arrows coming from A to A. So that means there must be some other element here that gets mapped to twice. Must be. Because we've got n arrows. But this one didn't get mapped to. So that means some other element must have got mapped to twice. Right? But that's not allowed because F, you're told, is injective. Right? You can't have any 2-to-1 mappings because F is injective. And therefore you must have 1-to-1. Right? It must be 1-to-1. Now if it's 1-to-1, if every point is mapped to 1-to-1, that means every point in the codomain, every element, is mapped to. Yes? 1-to-1. But at least it's mapped to every element. And that means by definition that it's surjective. Okay? So if you're mapping a finite set from itself to itself, and that mapping is injective, therefore it must be surjective. So that's true. So the statement was true. An injection from a finite set to itself is also a surjection. Alright, now question 5 is similar. An injection from an infinite set, so that's the difference, to itself is also a surjection. Right? Now, So to make things a bit easier. Now, when you get a question like that, usually the first thing you think about is, oh gosh, do I try to prove it or do I try to disprove it? And you know, that can be a tough problem. So, right, so here's the wording. So an injection from an infinite set to itself is also a surjection, question mark, true or false. Probably psychologically you're guessing if this one were true, then probably this one's false. But you know, maybe it's a trick question. Well, what do? Do you try to show that it's true? Or do you try to find a counterexample which means it's false? Now, it depends on your gut feeling. Do you suspect that it's false? If so, then go hunting. Your strategy would be then to find a counterexample. If you suspect that it's true for whatever reason, well, then you need a proof. Right? So it's up to you. Well, we can go either way. Let's start with maybe it's false. So that means we need to find a counterexample to prove that it's false. Well, find an injection. Find an example of a mapping that is injective, and then show that it's not surjective. That would work. That would be a counterexample. But you need to find what that mapping is. Well, here's one. You're mapping the set of integers to itself. Okay, now it's an infinite set. The set of integers is an infinite set, and you're mapping itself to itself. Right? So every element here gets mapped to. Oh, wait a minute. I need to specify in detail what the function is. This is mapping from set to set. Here's the actual detailed from member to member way of writing the function. So you take any integer n and just double it. Okay. That function is obviously injective, right? Because what does it mean? It means this set here, all the even numbers here are mapped to. The odd numbers are not mapped to. That says something. So the odd numbers here are not mapped to. Therefore, this mapping cannot be surjective, right? Because there are elements in this set, your codomain, that are not mapped to. Surjective means every element of your codomain is mapped to. But here, the odd numbers are not mapped to. Therefore, this function is injective, right? You can see that because every element is, if it's even, it does get mapped to, and if it's odd, it does not get mapped to. That's okay. Injective means mapped to at most once, so once or not at all. So it's injective, but it's not surjective because the odd numbers are not mapped to. And to be surjective, every element in your codomain must be mapped to. Alright? So you found a function that is injective, but it's not surjective. So this statement 5 here, well, you can read it here and just change these words. So an injection from an infinite set to itself is also a surjection. No, because we found a counterexample. This function f that just doubles your integer f of n is 2n. Right? Doesn't work. So that fifth question, an injection from an infinite set to itself is also a surjection. That statement is false. Right? Well, I have now officially finished this course. I thought I'd done it with the previous session, but I found one missing. So the next time you see this whiteboard, well, let me rephrase that. My next use of this whiteboard will be it'll be a physics course. So it'll have here math physics. It'll be quantum mechanics. It'll be at senior level, and the author is Davies. And it'll be lecture 1, and what is it? Preliminary concepts about quantum mechanics. Okay, so that's it.